Hello guys, I hope you're doing all right, and here we are in a new video, and it's about the Pythagorean theorem. Okay guys, so on last week's we were talking about the square roots, why are so useful to use the square roots to solve many different problems. And here guys, we have a very important application that is called the Pythagorean theorem. Okay, so many applications, guys, of the square roots require the use of the Pythagorean theorem. But the question is, what is the Pythagorean theorem? So here we have that it's a theorem that can help you to find a missing side of a right triangle. Guys, remember that a right triangle is the triangle that has a right angle. What does it mean, a right angle? That this is 90 degrees. So here we have the right angle, which is 90 degrees. All right, we have two sides that are perpendicular. Okay, here we have the leg A, which is the vertical side. Here we have the leg B, which is the horizontal side. And here we have the hypotenuse, which is the side C, or the diagonal. All right. So guys, what is the equation to of the Pythagorean theorem? Here we have, if we have the right triangle, we have the sides A, B, and C. This is the general equation that we are going to use. Okay, and this is A squared plus B squared equals C squared. Okay, so it means it's the sum of the legs, the square of the legs equals the diagonal to the power of 2. All right. So guys, if we have this equation, how can we find, for example, the side A? How can we find the side A? So here we have, since we have an equation like this, the side B, it comes to the other side, but with the opposite sign. So that would be negative. All right. So that would be C squared minus B squared. All right. It comes to the other side negative. And the same if we need to find, for example, the side B. Okay, if we need to find the side B, then we take the side A to the other side, and that will be B squared equals C squared, which is the diagonal, minus the side A to the power of 2. All right, so they are the equations to find the side A and the side B. If we need to find the diagonal, we can use their general equation, which is this one, A squared plus B squared equals C squared. All right. Okay, guys, let's see an example. How can we use this theorem? All right. Here we have the first example, and it says, find the unknown side of a right triangle in which the sides are A equals 12 centimeters and B equals 8 centimeters. So we have the same triangle that we saw before. We have with its corresponding right angle right here, and it's 90 degrees. All right. The side A is 12 and the side B is 8. So in this case, we need to find the side C. All right. So it means the diagonal, this side. All right. So guys, we can use the general equation that we already have. So A squared plus B squared equals C squared. So we are going to replace these values that we already know, A and the side B. So that will be, for example, here we have the side A will be 12. So here we have 12 squared plus B squared. So that will be plus 8 squared equals C squared. All right. So guys, here we can use the calculator to find these powers. So for example, the first one is 12 squared will be 144. So here we have 144 plus 8 squared, which is 64. And it equals to C squared. All right, this is the value that we are going to find, the side C squared. But here we have a problem, guys. Here we have an exponent in the variable, but we don't know, we don't want to find the exponent. We need to find the value of C, not of C squared. And now, guys, here we have the way to use the square root. So the way how that we can use to cancel this exponent 2, we can use the square root. All right. So we are going to apply the square root at both sides of the equation. All right. So we are going to find the square root of this, and then we apply the square root in the variable. So that way, guys, when we have the square root of a variable to the power of 2, remember on last lessons that we can simplify, we can cancel the exponent with the root, all right? So that will be the value of c. So finally, we have the square root of 144 plus 64, all right? This is equals to the side c. Now we already get rid of the exponent, all right? So we can find the value of c alone. All right, guys. So what happens, guys, when we have an addition inside the square root? So first we need to solve the addition. We need to find the sum of these terms. So we add 144 plus 64, and that will be 208. So that will be the square root of 208. Okay. So we have the square root of 208 equals to the side c that we are going to find. Okay, guys, so we are going to use the calculator to find the square root of 208, as you already know. So the square root of 208 will be 14.4222. Okay, so here we have a lot of decimals, guys. When we have a problem like this, guys, we are going to round to the nearest 100 position, to the nearest 100. Okay, round to the nearest 100. Okay, so what is the nearest 100 in this decimal? So we are going to approach the second decimal position. So we are going to cut this decimal, and we check that the third term is lower than 5. This is lower than 5, so we can approach this decimal to 14.42. For example, if we had here a 6, so we can increase the second decimal place to the next whole number, so that would be 43. If we had 6 here, so that would be 43, 14.43. But in this case, this is lower than 5, so that will be 14.42. So this is the side C, all right? We already know the value of C. Okay, guys, that's it with the problem. We already found the value of C, which is 14.42, all right? This is the value of C, 14.42 centimeters. Because remember, if we are talking about centimeters at these sides of the triangles, the diagonal will be also in centimeters, all right? We cannot change the units. Okay, very good, guys. So let's continue. Okay, guys, so let's continue now with example 2, all right? We're using the Pythagorean theorem. So the example 2 says, find the unknown side of a right triangle in which the sides are A is 4 centimeters, we have C equals to 6 centimeters, and we need to find, so the missing angle, the missing side here will be B. So we are going to find the value of B. We already have the value of A, we already have the value of C, okay? So we are going to use the same equation, guys, okay? A to the power of 2 plus B squared equals to C squared, all right? So guys, how can we find the value of B in this equation? Remember that now we are going to leave the B alone here. So we need to move this A to the power of 2 to the other side, but with the negative sign. So that will be B squared. We are going to find the value of B. B squared equals C squared. We keep the value there, C squared. And this A to the power of 2 comes to the other side, but negative, minus A to the power of 2. Okay, remember the theory that we checked before. So guys, we're going to replace the value that we already have. We already have C, and we already have the value of A. So we replace this variable, these values. So that will be B squared equals C squared. So that will be C will be 6. So will be 6 squared minus A squared. But A is 4 centimeters. So that would be 4 squared. Okay. All right, guys. So here, remember that we need to solve these exponents. They are powers. So that would be B squared equals to 6 squared. That will be 6 times 6, not 6 times 2. Be careful with that. That will be 6 times 6, which is 36, minus 4 to the power of 2, which is 16. All right, so that would be 16. So in that case, guys, remember that here we can subtract 36 minus 16, and that will be 36 minus 16 is 20. All right, so b squared equals 20. Okay. All right, guys, remember that we need to find the value of b, not the value of b squared. All right, so what do we have to do here? We need to use the square root. So we're going to apply the square root at both sides of the equation to cancel the exponent. All right, so we use the square root here, and we take a square root in the number. So we can cancel that way the 2 with the square root. So the value of b will be b equals to the square root of 20, that is 4.4721, and more decimals. Okay, guys, remember that here we are going to approach, we are going to round the decimal to the nearest hundred position. All right, so this is the 10th and this is the 100th position. So we're going to approach this decimal. We're going to check the third decimal place. If this is greater than 5 or greater than 5, we can approach this 47 to 48. But this is not the case. Here we have 47 2. This is lower than 5. So we are going to keep these decimals, 47, 4.47. So the value of b, finally, the value of b will be 4.47. Remember the units, we're talking about centimeters. So these are centimeters, okay? So b equals 4.47 centimeters. We already found the value of c, okay? All right, guys, very good. So here we have the second example of Pythagorean theorem. Okay, in the next video, we are going to see 2 additional examples so you can understand much better. Okay, so see you in class, guys. Bye-bye.